Thank you, Paulina, for this nice introduction. I can start with reflecting on what you picked up from my CV, my patents, because I spent so many years working with AI research. But now it's not research. Now we need to move into reality. Now we are building it for real. And in this talk, I will be discussing the symbiotic relationship between AI and telecoms. And that's kind of my thing, because I'm this software person who, did a PhD in software many, many years ago in cyber-physical systems in AI, and then jumped into the world of radio systems, right? And since then, I was trying to navigate in this big company that's very focused on radio systems. And luckily, there is a very good symbiotic relationship between those, because it is a software system, because our 5G systems are majorly consisting of software. There's a huge amount of data flowing throughout the network. So there is a great potential for algorithms, AI algorithms, to be applicable in the telecom space. But I will tell you more. This technological convergence, or whatever we call it, symbiosis or technological convergence between telecom network, AI, and compute, it's very interesting because they're fueling each other. And since a couple of years ago, the telecom market, our dear customers in telecom market, they kind of were struggling of finding new revenue streams, because we know that telecom networks are about delivering quality of service to their consumers. We use our phones. We use our mobile internet, and we are just expected to go faster and faster with every generation, and we expected to have bigger bandwidth, lower latency, and that's kind of what followed with every G, right? 5G is slightly different, because with 5G we said, let's enable the whole range of different use cases coming from industry. So it's not just your video stream or your internet, but it's also the network for industries. And going back to when 5G was launched, and it was a huge competition between operators in US and in South Korea, where they said, we want to be first with 5G. Let's go first with 5G. And they went with 5G, and they released 5G, and then they subsidized the devices. So 5G-enabled phones and 5G-enabled headsets, they were half price for the consumers. Why? Because they wanted to untap the market and see what will pop up there, right? What is popping up there? Because kind of those tech enthusiasts like us, we didn't know really, because we know how to build very nice telecom networks. But the creativity is out there. The creativity is in the community, and the business ideas are in the community. So how do you enable the community? Well, you enable through APIs. Offering network slicing, differentiated quality of services, offering to the community. So we go into this technology democratization. Everything that's surrounding the AI and compute and telecom network are being democratized through the API access. And we've seen this with recent advancements with AI, obviously. Now it's booming. Now everyone can really access it very quickly through APIs, and you can, without knowing how to code, build your application. Sorry. Build your application very, very efficiently. And the same thing the developers are being able to make with the telecom networks nowadays, because their API is being offered. And with the compute, we know that as well. Their big hyperscale is offering very simple API access. So anywhere in the world, anyone without having a deep knowledge in coding or a deep knowledge in telecom systems, if you have a great business idea, you start building. This is the democratization of this technology, which is really cool. But coming back to how do you kind of increase this market, right? How do you actually increase the telecom market? That was kind of top of mind thing, because you want to make a bigger cake, and then everyone gets a slice of a cake, and each slice is bigger. Just by providing services that are faster and bigger bandwidth, that doesn't really cut it, because everyone is expecting it, right? So what are the key services? What will drive the new technology innovation? What is the new, what do we need in 6G? And there are certain things that have specific characteristics that are very driving for telecom network development. And I'm really an early adopter when it comes to technology. I buy it immediately, and I'm this person who says like, shut up and take my money. Whatever something is released, I buy it because I just love technology innovation. So when we were starting to talk about 6G and the driving use case and AR and VR, it's like, come on, this is old stuff. It's out there. I've been using this AR, VR for years. Like, how are you talking it's a driving use case? And then I figured that the key part here is that it is at scale, that it's accessible, and that the whole society is using kind of widespread service at scale. Because then it's difficult. Having 2 headsets running on your network is easy. But when you have the whole world population using some kind of headsets, this one becomes difficult. That's challenging for the network. That's a big demand for the network. And big demand for the network, that's a luxury problem, as we call it. Because then you need to build more, and you need to develop more. Other things that are listed here, obviously, if you have, if you are in a, Scania truck, you have a lot of compute power on the truck. You can afford to put a lot of compute on that. And you can afford to have a lot of local processing of your loads when you scan the network, when you scan your surroundings, when you have this video feed and you need to process it. When you wear very slim AR glasses, you don't have this compute power, which is good. We don't want to wear heavy things. We want us to be stylish, right? Mobility is kind of another good factor, but it's not a must anymore because it's more about quality of service. When a thing is moving around, that's extra good as a use case for someone like me because it kind of motivates why it needs to be 5G connected. But it's not a must because the cool thing with 5G connectivity is that it gives you quality of service compared to Wi-Fi. Then, of course, latency requirements, some that needs to happen instantaneously, that you don't have a delay. You've seen these examples with the distributed, concerts, especially during COVID times. There were many applications when musicians would meet online and perform, and then it needs to be really synchronized. That's low latency. Bandwidth requirement, going back to this AR examples or whatever, the robotic dogs, how cool. It means that they are taking a huge data feed and processing right there and making some decisions. And, with all these regulations coming in different countries, it's varying per country. And maybe if someone takes in a data feed and needs to process it and transcribe it in real time, and maybe you need to translate it to a different language, and maybe you need to filter out some faces, and maybe you need to adjust to the regulation. So like a lot of processing being done there. And a lot of processing means that you need to have a lot of compute somewhere. Quality of experience already mentioned. In some cases, you just need to have good enough quality for your service, otherwise you cannot do it. And also, what I wrote here is stream processing. It means that you're doing the processing of data in real time, as opposed to, okay, let me run it at night when everyone is sleeping and the network is not loaded, and then I can run it like my training. But in certain cases, whenever, a robotic dog is somewhere on a construction site that has a problem and it needs to rescue a human, it needs to be doing the processing in real time. So these are good characteristics of any kind of generic use case. Now I've talked about generic use case, but I will specifically talk about one that's a very good driving use case for the symbiosis of AI and telecom network. And that's obviously Apple Intelligence. There are many other ones, but Apple Intelligence is a very clear case that they announced. The slide comes from Worldwide Developer Conference this year, and essentially what they're saying, we have intelligence on device, and then we have intelligence in the cloud. And we're doing something on device with the small language models, or they call it tiny language models, 30 megabyte language models on device, because on device you have just limitation of the RAM, CPU, GPU, and the engines, so that part. And then you have the huge compute on the cloud compute, where you have the GPUs, the CPUs, and you have a lot of capacity. So that link in between, as you can imagine, that's a telecom link that needs to guarantee you the quality of service. Because when you use your Apple Intelligence on your phone, it needs to react instantly, right? So that's kind of, and obviously they have also a connection to OpenAI, ChatGPT 4.0, and so on. So there is a lot of integration and a lot of network being involved in this kind of architecture. So this is a cool driving use case. And out of these driving use cases, since they were kind of on top of mind of many telecom operators, many device vendors, many universities, we formed something called AI Run Alliance, AI Radio and Access Network Alliance. And that's new. We just announced it very recently. It's been founded by Ericsson. Well, this is the founding members, but specifically Ericsson, T-Mobile, and NVIDIA, that are kind of the first founding members, saying like, okay, now we need to really look into how we apply AI, how AI and radio access network integrates and interplays. And even though it's a catchy name, for me it sounds really nice, AI Run, right? But it's not just Run, it's more than that. It's actually the full telecom network. It's also core, it's also transfer, but I'll come back to that. And it has 3 pillars, as you can see here. It's AI for RAN, it's AI on RAN, AI and RAN. Okay, I'll explain. It's rather AI for RAN and RAN for AI, I would say, but this is the convention, the naming that they chose. But let's go into these 3 categories. So AI for RAN, this is what we call AI for telecom networks. That's my day job. That's what we do to make, that's how we use AI to make telecom network more performant. And telecom network is well, it's a big system with many different timing characteristics. So in this picture, maybe you can't see, but very quickly I will explain. So the control loops that are happening in the system, they vary between microseconds and weeks. And this is how you control the radio access network. You have like super fast control loops, milliseconds in the layer 1, layer 2, in the radio access network, when it comes to optimizing the scheduler, for example, that optimizes the routing the packets. And then all the way to weeks, where you have the management of the network, when you need to predict some kind of degradation. Degradation in the network, you can predict 9 minutes before something will happen. Then you can sit and optimize some performance in the network on the higher layers. So anyway, so it's all connected. So there are many different timing aspects here. And the lower you go, the more fun it is, because it's super challenging and you have the real-time constraints, really. The upper you go, the easier it is, because it's kind of, there's a lot of low-hanging fruits there because of all the network management and ticket correlations, and you can do a lot with AI. About the kind of what kind of wins we're looking for here. We have the total cost of ownership, new revenue streams, customer retention, service velocity, and internal development efficiency. Maybe enough for AI for RAN, but RAN for AI, it's specifically addressing this type of use cases, such as Apple Intelligence. When we have a lot of AI processing that needs to happen somewhere, then you need to compute on the network because you need to distribute it on the edge. AI and RAN is another work stream that looks at how both AI as a technology and RAN will benefit by sitting together on the same compute. Right. So now, if you remember this, the microseconds and days, that's exactly the same, but similar kind of distribution of. But now you see the full stack. Now kind of I unfolded the world radio access network into all the layers that we have. So they have the radio access, they have telecom, you have the transport and core, you have the cloud. Then the higher you go, the longer the control loops become. You have the network management, you have the cognitive core, you have the operation support and business support, you have the enterprise wireless solution, and they have the exposure through APIs. So you go up the stack, and going back to generative AI, normally, generative AI as technology is easier to apply in the higher levels. But I'm not saying it's not applicable in the lower levels. It is applicable in the lower levels. But on the higher levels, it's more obvious. It's easier. Because the higher levels, they don't require very low latency when doing the compute. Then we also studied what we looked at. We studied the centralized versus distributed AI in the network, for the network. Because the higher you go, kind of, in the layers, there are a lot of common parts. There are a lot of common parts. And the lower you go in the components, there are very specific algorithms that need to be adopted for the certain component. But in the higher parts, you have, for example, intent-based analysis, network-wide coordination, you have possible human interaction, you have the generative AI framework, you have the MLOps, you have LLM ops. Yeah, you have a lot of these things. You have the data lakes and so on. But let me just show you quickly, specifically on why Ericsson is building our own foundation model. Because we see a lot of benefits. You know, there are so many models out there. They're great. And we're working with all of them. But we also need to have a certain precision and certain CO2 footprint. That's kind of the two main reasons behind the quality and the footprint. Because telecom market and telecom domain we are not solving a Turing test here. It's not something that you will know that this is something that's addressing your telecom problem. It's not a generic AGI that you're talking to. And if you are not solving the Turing test, then you can actually build a very specific and small model, which is very cool. So these are some numbers of comparison, how it compares to so there is a test. This is the 3GPP-based Q&A test that we've run and experimented on different models, Gemini, GPT, GPT-4, and they are also using the RAG boost. So we're using the RAG solution always, obviously. But then, if you compare, actually on the right-hand side, there's something called ELI, and that's Ericsson Language Intelligence, which is our stuff. But our stuff is just a framework incorporating a lot of different models. And it performs much better. It does perform much better. Not revolutionary much better. But the cool thing is that it's also smaller. Because if it's smaller, then it can be also more reactive and give you answers quicker. And it can, well, it doesn't need to use as much CO2 footprint. And there are 3 different ways of doing it in general. You can just use whatever is out there on the market. It's off the shelf. It's Llama, it's Gemini, it's GPT. You use them off the shelf, and then you apply, you go with your RAG, you feed in your RAG solution, and you get a certain accuracy. This is very convenient because you can integrate it within days, and you can get certain precision, but it's very quick. The second one is to take a pre-trained model, take Llama, and retrain it on your domain, which we did for telecom. And that gives you higher precision, but then you need to invest your R&D, obviously, in building that. And the third way, which is kind of extreme but works for certain cases, is actually to build your own foundation model. It's not an LLM, it's small. It's it's an SLM. It's a small language model, but for certain cases, it makes sense, for certain limited domain, it makes sense to have a smaller one, because it will give you the precision and the speed. And we have a number of commercial offerings on that already, which are assistant for radio access network, assistant for our Vonage AI Studio, which is a developer APIs to access the telecom network, AI-based net cloud assistant for our abuse network solutions, and the trouble report identification. This is just some examples for you. But the coolest part is not a chatbot. It's not that you can talk to something. The coolest part is that this thing, whatever it is and how you build it, if it can, in real time, connect to all the parts of your network, or whatever solution you have, doesn't have to be a telecom network, can be anything. If it connects, then it can, in real time, trigger and pull the data from different parts of the network. And we call this concept talk to a network. So it's towards fully automated cognitive network. When a human or that type of robotic dog, whatever is connected to the network, is saying, I sense something. There is some problem that's going to be about to happen. How can you help me? And the network starts to self-organize and figure out where the problem is and how to execute it. And with that, I end my talk. Thank you very much.
Thank you. We haven't received any questions from the audience. Well, we have received two, which are both, what's the password for the Wi-Fi? Which says a lot about connectivity, but also there is mobile connectivity. But we have a Wi-Fi, we have a password, but let's save it for later. I will give you that info eventually. So thank you. I was ready to listen to 30 more minutes about this. It's super interesting. The obvious question is, and the big question within this field, and I noticed that a lot of people ask me about it too, sustainability, and you mentioned it. You want to train your own foundation model because then you can control the climate impact that it has.
Yeah.
Can you tell us more about that? In what ways are you working, and what are the sort of key ways of actually achieving? Is it even possible to achieve green AI?
Yeah, it's a very good question, absolutely. And again, there are two ways. So one way is to make the telecom network as such more green, more sustainable, and there is a lot of AI algorithms there because it's, in simple terms, it's about kind of predicting the need, what is the need for the network, and then you can execute like the power saving modes, and you can put some cells to sleep, obviously. But to control the AI's consumption, energy consumption, I think it's more important. I think this combination, I would say divide and conquer. Solving a Turing test, that's a really cool application, but it's not doesn't save the world, right? We want to save the world by addressing specific tasks, but by very focused AI application. And even telecom network as such is a combination of many different domains. So for each domain, you can have a separate model that is small, and then they communicate between themselves.
Yeah. So are you saying that in the future we will become more sort of well thought through? We have clear strategies and sort of regulations maybe even for when to use AI and not?
Oh, that's a different topic. Regulation is a huge topic.
From an energy perspective.
From an energy perspective.
Yeah.
But I think a lot of, since I'm a tech person, a lot of things can be solved by having the right computer architectures.
Yeah.
I think when you start innovating, then we're just going with kind of like what's happening, what we're seeing now, it's a lot of compute power is being invested. There's huge investments, but this is an experimentation phase, right, in the world. We're experimenting, we are burning a lot of CO2, but we are in this transition experimentation phase. If you kind of, in the future, consider a collection of smaller models or hierarchical architectures, then they will be much more efficient and precise. Regulations, that's a separate topic because obviously each part of the world have their own. And as I kind of indicated here also, whenever you use any kind of AI-enabled device, it behaves in different ways in different parts of the world. Yeah. So I live in the US, and when I bring my stuff into Sweden, they stop working essentially. Yeah. And that's very energy saving. When the AI is blocked completely, it's perfect. And the telecom network as well. Like we can power it down, and then we save a lot of CO2.
I think I can sense some sarcasm here.
Oh no! What do you say, bazinga? Like Sheldon said.
True. Yep. So we have some questions here. How can telecom operators benefit financially from new AI features? You mentioned some of the use cases, which I guess also have financial sort of incentives, but...
So there, I mean, AI is perfect, I think, for telecoms financially, because AI in essence, also in very, very simple terms, AI is there to compensate for the network's imperfections. Because let's be honest, it's not perfect. And it's not, we don't have unlimited resources in the world. Network is a limited resource, spectrum is a limited resource, our planet is a limited resource, we have CO2 and so on, so we have so many constraints. So whenever something bad is about to happen in the network, say something fails, that would be very costly for CSPs or for operators to address. In the worst case, it will trigger a power down, maybe like even the whole city will be without connectivity. That's huge economic consequences. They will need to pay fines, and they will need to send people to repair. So any kind of predictions of that in that sense, they are great, because then you can kind of, you don't end up with this unwanted situation. So any kind of prediction of some unwanted states, this is great. The second one is kind of optimizing the limited resources. Because when you kind of roll out your infrastructure, you start rolling out your infrastructure in the city, but you want to cover as much as possible with your limited, equipment that you bought from a vendor. That's one. Another one would be spectrum efficiency, because spectrum is very limited resource and very costly. So you want to get as much as possible from a spectrum. So there's a lot of savings. But also, I mean, there are also new business opportunities that you can see happening through AI, and that generative AI plays a good role there.
So we're almost over time, but you traveled here all the way from Silicon Valley, so I'm going to ask you one more question and use this time as much as possible. How does Ericsson work with AI-related risks? You talked about sort of the collaborations that you have with other AI companies, other tech companies, the pacts,
So,
but what else?
From different direction, I would say, because when you work with a risk, I mean, there's always kind of a balance between risk and opportunity. You cannot, like, how defensive can you be, right? So that's one. So we need to take, I think, very calculated approach to risks. I'm probably saying from my heart, because being too afraid and not to deploy AI completely, that would not be smart. That would be a big risk in itself, right? But the way we work with it is obviously we analyze the risk, we work top-down together with regulators and authorities and monitor, kind of try to influence that the regulations are written in the right way, so we are regulating the use cases and not the technology. It's in many different countries. I mean, we specifically analyze the AI Act and the regulations in UK, in US, and in Canada. They are different. So that's why I'm saying the devices behave in a different way. So that's the top-down, how to kind of, you make sure that the guardrails are written in the right way. And then when they are written in the right way, in words, we need to translate them in the technical requirements. Like, I mean, if it says your algorithm needs to be explainable, right? Then we need from bottom up establish the explainability algorithm. We need to build it, and we have a team or several teams working on specifically transparent, explainable AI algorithms that address the regulations. So they have top down, you need to do this, and bottom up, we build the thing that adheres to.
Yeah. Great, thank you. Are you hanging out here at the conference?
Yes,
so people will have more questions they can
perfect.
just talk to you. Thank you so much, Elena. Another round of applause.
Thank you.